In this video, I'd like to discuss lipids. This is another major type of biomolecule. Lipids are known for their insolubility in water. They're found in pretty much all organisms. Lipids are diverse in the sense that they include lots of molecules that are quite different structurally. So there are fats and oils. Those are very similar, and we'll talk about them. There are components of cell membranes. Those are a little bit different than the fats and oils. And the one that stands out that is being quite different structurally are certain hormones, which are steroid hormones, which we'll talk about in a second. But again, these are all grouped together because they have some chemical similarities. They're all primarily the main thing that distinguishes them is that they're insoluble in water, meaning that they do not dissolve easily in water. So after mixing oil and vinegar together to make a salad dressing, for example, they'll separate, and the oil, which is lighter, will end up on the top. So oil and water really don't mix very well, and oil is a lipid. And I actually did a picture of this. I took some water, and I added a little bit of blue dye, and then I added a little bit of canola oil. And what you can see what happened is that the canola oil essentially is separated from the water. And the reason for this is that canola oil is a lipid. It's insoluble in water, and it's also hydrophobic, meaning it's water-fearing. So even if you break it up, like say I mix this up a lot, you would still have droplets. You would still have these small droplets of canola oil mixed in with the water. It would never really become dissolved in the water. And you can see this picture here. We have butter, which is a lipid, which is essentially a lipid. It's an animal fat. And then we have two types of oil here. It looks like olive oil, and I think the other one is probably canola oil. All right, so let's talk about fats and oil a little bit. So fats and oils are essentially the same type of molecule. They're called triglycerides. These are going to be energy storage molecules. At room temperature, fats are solid, whereas oils are liquid. So that's really the only distinction. Is at room temperature, roughly 25 degrees centigrade, fats are going to be solid, whereas oils are liquid. And you can actually test this yourself. If you take some olive oil, I don't know why you would do this, but you could certainly put it in the refrigerator. It won't hurt it. And you'll see that it will become solid. So it'll look a lot more like a fat than a oil. So fats and oils in plants and animals are molecules called triglycerides, and they have a energy storage function in both plants and in animals. Triglyceride is composed of a glycerol molecule and 3 fatty acids. So a glycerol molecule, as you can see in the picture, is a 3-carbon organic molecule. And you can see there's a carbon backbone with the 3 carbons covalently bonded to each other, and then there's some hydrogen, and then there's some hydroxyl groups, the OH groups. Now, tri means 3, and so the glyceride refers to a compound of glycerol and organic acids, and then the tri means 3, and the 3 is referring to 3 fatty acids. Okay, those are the organic acids. So we have a fatty acid, which is a hydrocarbon chain, which consists of carbon and hydrogen. And then at the one end, there's a carboxyl group, which is COOH. And as you can see in the picture, we have the glycerol and we have the 3 fatty acids. And then we go through a process called dehydration synthesis, which we've talked about in previous videos. And basically, you remove a water, which is H2O, and you have a number of 3 covalent bonds forming. And you can see a triglyceride here. Just above me, there's a triglyceride with the glycerol backbone at the top, and then the 3 fatty acids attached. Now, some triglycerides are saturated fats. So butter and bacon grease, are both made from animal fats. They're solid at room temperature. So why are these called saturated fats? Well, the word saturated means full. So saturated fats have as many hydrogen atoms as possible. So if we look at a triglyceride that's saturated, if we look at the fatty acid chains, you'll see that each carbon has as many hydrogens as possible. Essentially, there's about 2 hydrogen atoms per carbon atom. And because of this, the fatty acid tails are perfectly straight. And so with the presence of these straight tails allows the triglyceride molecules to pack very closely together, and they become solid at room temperature. As you probably know, a diet rich in saturated fat increases the risk for cardiovascular disease. So eating lots of butter, eating lots of bacon, things like that, a lot of animal fats it's a risk factor for cardiovascular disease, meaning that it increases your risk of having cardiovascular disease at some later point in your life. So let's look at the other kind of fat. Well, you have unsaturated fats. So some triglycerides are unsaturated. These molecules have double bonds that cause links in the hydrocarbon tails of the fatty acids. So if you look at the picture here, we can see, well, two examples would be olive oil and canola oil. And then if you look at the molecular model here, we have an unsaturated triglyceride. And what you can see is we don't have as many hydrogen atoms as possible. Some of the carbon atoms only have a single hydrogen atom attached to it covalently. And so because of this, it will have a double bond with a neighboring carbon atom. Now this double bond will actually cause a kink in the structure of the tail, so it's not perfectly straight anymore. It has this little kink. And because of this kinkiness, this means that the triglycerides don't pack together as well as they would if the hydrocarbon tails were perfectly straight. And because they won't pack together as well, this means that they're fluid at room temperature. And again, these are said to be unsaturated triglycerides, and they're actually very healthy. So olive oil is an unsaturated triglyceride. It's fluid at room temperature, and it's quite healthy. It does have a lot of energy stored within it, so it can be fattening. Okay, so that's the downside with olive oil or canola oil. But in terms of the fat content and it sort of clogging your arteries, it really isn't a danger at all. So unsaturated oils are much healthier compared to saturated fats. I want to just very quickly point out, so that's basically all I really wanted to talk about. But so we've talked about saturated fats. So you can see the nutrition label here. I don't know what this product is for. It's something, it says total fat, and 12% of that is saturated fat. And presumably some other percentage would be the polyunsaturated fat. Poly simply means many, so there are more than one region where there's a double bond or a kink in the fatty acid tail. And monounsaturated fat, that would be that's also a fairly healthy one. That's, again, mono simply means there's just one double bond. So there's one kink, and yet that's enough. That's enough to keep it from packing together very easily at room temperature, and so it wouldn't be solid at room temperature, and it's quite healthy. Now, the last thing I just want to quickly mention, because it's kind of a big factor for health, is trans fats. So trans fats are actually synthesized. What they do is they take typically unsaturated triglycerides, and they expose them to a chemical process in which they actually put in a double bond between carbon atoms in the hydrocarbon tail. But unlike the ones that are healthy, which have this kink in them, these double bonds lead to a straight structure. So the hydrocarbon tails, even though they have double bonds, are actually straight, and they pack together and they're solid at room temperature. These tend to be the most unhealthy of all because they're not natural. So they're really the worst possible combination of packing together really well at room temperature. In a solid way, which is not good. That's not a good sign. And then they're also essentially artificial chemicals. So they're the worst for your health. Okay, I'm going to stop there, and we're going to talk about some more lipids in the next video. Thank you very much.